Okay, offline had a student from group 7 answer that. The basics. And if you, hopefully you've seen the other cosecant, secant, cotangent. If not, know who flips with who. Remember what I said? Sine and cosecant go together. There's only one co in a reciprocal relationship. Cosine, therefore must go with secant. And then tan and cotan. Is that getting annoying? All right, fine. That's how I teach. Adjacent over hypotenuse. So what does that mean? Who am I going to use? What trig function? Cosine of who? Some people jack this up. Equals who? 20 over x. Just the student in question. And then what would I have to type on my calculator to solve that? So what does x equal is what I'm saying. Like, don't actually find it, but what would I have to type anyway? What would I have to type on my calculator? Sorry for my equal sign being jacked up. Calculator, so that's what you would type. Switch these two is what happens when x is in the denominator. And then make sure your calculator's in what? Degrees. It's your responsibility to make sure you see a D up there. Okay? Alright, this is actually based off of the worksheet that we had the other day. So Isabella, help 3. Student groups 3. See now, Dejana, and I remember passing these papers out, and I don't remember from Friday. So what's your name? Sarah? And what's your name? Sydney? Is that what you said? Sydney, we'll start with you. What's the setup? Okay, so tell me what I'd write. You have two choices of what you want to write. So you're probably saying x equals, right? And then what'd you say? It's inverse tan of who? Yeah, and then don't. So actually, you got it ready already. You could have said tan of x equals 30 over 14, and then ultimately you would have to do this anyway. I really have nothing else to ask you on this one. That's it. You type inverse tan of 30 over 14, get an angle measure. Next, what's the next setup? Set up the equation for this one that's true. And then just to put it all together, last student in this group, what would I type on my calculator in order to get this answer? So it's just switch the x and the sine 55. Okay, so before I get into those, that's just a regular, all that stuff that we already did from last week. I think Tuesday I gave you that. I'll give you a second to write this down as I prepare for, what we have to talk about today. This is called coordinate trig that we're going to do almost all year long. And then this first set of statements are going to be the key for you to be succeeding in like 7 out of the 8 chapters we're going to do up till December. Up here, I denote some popular Pythagorean triples. I think everyone better know at least 3, 4, 5, right? Right? What does that mean? What it means, I ask questions and answer myself, illegal teacher. 3 squared plus 4 squared equals what? 5 squared. Obviously the biggest number is the hypotenuse. But what a lot of people don't remember are these. You might want to make the note to self. I bet you some people know 5, 12, 13. Then after that it gets a little less popular. A lot of people don't remember 8 squared plus 15 squared equals 17 squared. Same thing with 7, 24, 25. They're not the only ones. These are the first 4 though. And then there's actually an infinite amount of Pythagorean relationships after this. So if you know those, you'll be able to do right triangle trig pretty easy on those situations that occur. Now, what we have a note here off to the side is how your triangles are actually going to be drawn. This is all coordinate trig. Who's the first coordinate listed, everybody? Who? Who's the first coordinate listed? X. So that is how you move. You move X first. You put your pen on the paper and say, okay, I have to move X, comma Y. That's your annoying pencil making that noise. And then you snap back to the origin. What kind of triangle do you got? A right triangle, because you're moving it for X and Y. So, of course, we have an angle measure that's created here. I cannot overemphasize what I'm going to tell you next. This is the theta that is the the actual angle Standard position from the positive x-axis to here. By the way, what would be a reasonable angle measure for that? Take a guess. There should be a whole bunch of answers, but everyone should at least have an answer that's what? 150, 140, 135. Hike. Okay? It's actually a number between what and what? 90 and 180. But what it creates also is what's called this reference angle. By the way, what's that reference angle between that I just circled? What would that reference angle be between? 90 and? No. 90 and 0. 0 and 90. This is acute. Aw. All right, now, using this reference angle, of course we have an opposite side, right? An adjacent side, right? And then, of course, a hypotenuse, opposite the right angle. But this is what the key is. I swear to whatever you believe in. If it's nothing, fine. If it's something, keep it to yourself in this public school. If you do not get this next point and it takes you forever, you're doomed. So this is important. Notice, no matter how I draw my triangle, if I look at this reference angle created by the angle itself, the y coordinate ends up being the what side? I'm pointing at it. Opposite. The x side ends up being the what? And then I did tell you this Thursday or Friday. The hypotenuse shall now be called what? R. Why R? What did I tell you R stands for? Radius of some magical circle called the unit circle. So go ahead and write that down. And I just said that. I'm not going to say it over and over again on the YouTube for billions to hear. They might tune out, and then I make less money. So what's the acronym again? Everyone say it. SOHCAHTOA. Now wash that out of your brain. What did I say opposite is the same thing as? What's the opposite the same thing as? Y coordinate. What's the hypotenuse now called? So now it's not so, it's sir. What did I say the adjacent side was? X. What's the hypotenuse? Kixer. What's TOA? I already said, I'm not doing that. All right? You're doomed if you don't. What's TOA? What's the opposite side again? And then what's the adjacent side? So everyone say, Sir, Kixer, Tix. Sir, Kixer, Tix. It flows right off the tongue, doesn't it? Sir, Kixer, Tix is now your new acronym for what is trig when you're dealing with coordinate planes. And the angle measures in coordinate planes. And of course we said sine is so cosecant so sine is sir, so cosecant is, just say those two letters. Just say R over Y. Rye. All right. Cosine is kixer, so secant is R over X. Tangent is Y over X, tix, so cotangent's X over Y. And all it is because the opposite side is always the y coordinate. The adjacent side is always the... it just blows my mind that students that just can't get this acronym. Sir, Kixer, everyone say it. Sir, Kixer, Tix. Let's do it 3 times. Sir, Kixer, Tix. Did you hear him? Did you do it? Oh, boy. Do not write the next example. Just use this as like a reader about what you're, I'm reading this. Okay, this is what I'm doing today. So this is all your work. So don't look at this right now. Just read the question up here where it says the terminal. What's terminal mean? Ending side of an angle theta. Get used to what theta is. It looks like a cracked egg. It's a variable. It's a Greek letter. Okay, in standard position. What does that mean in standard position? It means I start here, positive x-axis, and it should say a positive measure. You're moving this way in some way, and you end up in some quadrant. Passes through this point, though. So this is how you do it, and then I'll show you the answer. You do this. Okay, I draw my coordinate plane. Okay, 8. Which way do I move for 8, everybody? Right, left, up, down. Right 8. That's your pencil. And then what do you do for 15? Up, and then what do you do to complete the triangle? Snap back to the origin. So this terminal side passes through 8 comma 15, that gives you 2 of your side measures. That's 8 for that side, that's 15 for that, and this is a right triangle. Then, where did 17 come from? Where did 17 come from? Pythagorean Theorem, but this is one of those Pythagorean Theorem triples. Isn't that fun? Okay, so if you know 8, 15, 17, you can just write 17. If you don't, you do this next. You do the Pythagorean Theorem and get 17. Oh, by the way, let's go back up here. I kind of snuck that in here. This is important. This means R is always, always, always positive. Okay? Only X and Y can be negative depending on what quadrant you land in. Vice versa. You'll see that in the questions when we get more complicated with this. So R is always positive. X and Y may be negative depending on what quadrant you end up in. Okay, so back to this one. This is why 17 is here. Really, when you square root, you're supposed to put a plus minus on this mathematically, but R is always positive. Now, I will be honest. This one you could have gotten away with SOHCAHTOA, because what side is this? What side is this compared to this angle measure? Opposite. What side is this according to this angle? Adjacent. And then this is the hypotenuse. And you will be able to get away with SOHCAHTOA for a while, as long as you understand, that is the angle measure. All right, and then you can play SOHCAHTOA and hopefully make sense out of the ratios you see there for angle. Maybe you want to write this one, although I have more examples of it later, because this may be the first time in the history of your math life you see some negative answers for trig. But you don't have to. So notice, terminal side of an angle in standard position passes through this point. So I'm going to move in on this. And then give you a couple things that you should be aware of. I do have a visitor. -3, comma. Are you mad? You don't like this? -4. And then what do you do after this? Snap back to the origin. Now, the terminal side passes through this coordinate, sure, but really all you just need is that closed-in triangle there after I go back to the origin. Those that were in honors last year, you're bored to tears. That's fine, I don't care. Good yawn. Stealing oxygen from the rest of the class. All right, now how'd you get 5? You could do what to get 5? Pythagorean Theorem. And then this is where it gets weird. Okay, this is X, this is Y, this is R. Oh, this is what I wanted to do too. Let me zoom in on that picture one more time. Just for terminology purposes, you don't have to do this tonight, but I just want to get your head in the right spot. First of all, this is theta, starting at here to here. What's a reasonable angle measure for this? Greater than, but less than. So it's between 180 and 270. You're not finding theta today. Okay, just so you know. But a reasonable angle measure for theta would be between 180 and 270. Your calculator won't even spit that out at you right now. You're going to have to do something about that. What I wanted, is this is called theta prime in here. What's that angle measure between? It's always going to be between 0 and 90. And that's the relationship between these two. And you'll find that out later when we're actually finding angle measures, how to do that. I think that's more chapter 2. That's where the good stuff comes in. Now, if you wanted to write this down or not, remember, SIR, Y over R, KIXER, X over R, TIX, and then all you have to remember is cosecant, secant, and cotangent are just the simple flips of that. That's what you're going to need to do. Okay, I'm going to sit down for a little second before I collapse. And no one's going to do anything. You just walk over my body when the bell rings. Oh, looks like class is over. All right. Okay. -1, comma, √3. Hey, does anyone know what that number is? 1 √3. I know someone's got to know. Honors? 1 √3. No? All right. I did bother some people second hour, and it took longer in the notes, which is natural. I think I'm just going to go with it here. How could I find what this red segment is? How can I find it? Starts with a P. You know what? Forget it. I'm getting people. This student. Okay, what side is this? So here's theta. Here's theta prime that we can play SOHCAHTOA. But I don't want you to say that. What letter is that? This Y. This is what? And then what are we going to play? Not SOHCAHTOA, but Sir, Kixer, Tix. Okay, so you're ready. Play Sir. And I have it there for you. There's Sir. Sine of theta equals Y over R. So what letter over what letter results? What letter over what letter? What's sine of theta using these triangle values Y, X, and R? Sir, what's sine? What letter over what letter? I meant number. Yep, good. Square root of 3 over? Ooh, oh, and I put 2. Everything's getting all jacked up. I can't even write the right number. Square root of 3 over 2. Now we got a problem. What's cosecant of this angle measure? And then what do I got to do about that? I cannot leave this as an answer. Shh, Tim. Rationalize. Next, what's cosine of theta? You don't have the same issues, right?
-1 over 2.
Well, you got away with one then, because what's secant of the same angle measure?
2 over -1.
So it's just -2. Okay, now I'm going to make it difficult. What's tangent of the same angle measure?
Square root of 3 over -1.
I got no worries on that one. Now what's cotangent?
-1 over square root.
And then let's get this rationalizing done. What do I multiply top and bottom by for those that don't know how to do this? Multiply top and bottom by root 3. This is just -1 times root 3. And then this is freedom. What's root 3 times root 3?
3.
A free 3. All right? And you better get used to these ratios. You're going to see these like 1,000,000 times by December. 1,000,000! All right? Because you're going to see 30, 60, 90s a lot. Don't worry about this being a 30, 60, 90 right now. -2 root 3, comma -2, snap back to the origin. So the Pythagorean Theorem, you know, would look like this, right? R squared equals -2 root 3 squared. So you get more radical work. All right, now, what's -2 squared? I'll break this down for you. What's -2 squared? You're killing me, Smalls. 4. What's root 3 squared?
3.
What's 4 times 3? No, 4 times 3. 12. This squared is 12 because you square -2 and you square root 3, and then you multiply those two. What's -2 squared?
4.
What's the square root of this end up becoming?
4.
It is 4. By the way, those in the know, what kind of triangle is this? Anyone know? Oh, not 45, 45, 90. It actually is a 30, 60, 90. This is ahead of the game. You don't have to worry about that. Don't panic if you don't know that. It's just the multiple of that same relationship is all it is. And then next, you seem to be well with this. What's sine of theta? By the way, I know I keep doing this. This is theta, but this is theta prime that we can play Sir, Kix, or Tix off of. All right? Or SOHCAHTOA would have worked. So what's sine?
-1/2.
It's -2 over 4, which is -1/2, is what he already reduced. You always, always, always reduce. He did. Next. Oh, cosecant.
-2.
Okay, let's move on. Next, what's cosine? Write the full thing, and then we'll reduce it. Over what?
Over 4.
Is that what you said? I couldn't hear. And then how does that reduce? What does it become? You got it. You cancel those. Oh no. Now flip this. What does this become for secant? And I'll just make the whole thing negative out there. That's good. And then we really should have to not rationalize eventually. We should know exactly what this is when we rationalize. What is it, everybody? Do you know? Negative. Come on. 2 root 3 over 3. Okay, fine. If you are a bad rationalizer, you better get on board right away. All right? And then the last one I'll do. Tangent is Tix 2 negative over -2 root 3. Watch how I do this. And listen to my things. These cancel and these cancel, but I have a 1 up here. Don't forget that. What's 1 over root 3 become? Everybody, come on. Root 3 over a free 3. Because I multiply both top and bottom by root 3 to rationalize. Don't flip this. Don't flip this. Flip this before the rationalizing. What's 1 over root 3 flipped? Root 3 over 1. Otherwise, you flip this, then you get into rationalizing, it gets all, then you got to reduce. It's actually easier to flip before you did all that stuff. Flip wherever it's convenient. Okay, now I got to move along. I probably won't bother anyone, and I have everything written here. By the way, SOHCAHTOA does not work for this question. You have no way of using SOHCAHTOA. The reason is the coordinate is 0. How far do I move for 0? Nowhere, comma, -4. Where do I go for -4? Straight down. 0, -4. This isn't even a triangle. It's a line. It's a segment, actually. I lied. Geometry teachers would be going crazy. So how did R end up equaling 4? Because R is just the distance back to the origin. Isn't that fun? Or fine. What's 0 squared, everybody? What's -4 squared, everybody? What's the square root of 16? Right back to 4. That'd be a waste of time on this, though, because I could find what the hypotenuse is, even though there is no hypotenuse because there is no triangle. Well, you got no choice now but to memorize circ-kicks or ticks. Everybody, I'm going to be very sad if you don't get this right. What's sine, then, of this angle measure? This number, what number? -4 over this number. Y over R. By the way, I have a question. What is theta as an angle measure? You're not finding any angle measures today, but I know what it is. What is it? It is 270. Here's why. You start here. How far did I go? 90. How far did I go? How far did I go? That's why you're actually finding the sine of 270 right now. If you typed on your calculator sine of 270, you would get -1 spit out by your calculator if you're in degrees. Darn tootin'. What's cosecant then? What am I just going to write? -1. It's the flip of -1. It's R over Y. What's cosine of theta? Now it's time to talk about this. What's 0 divided by 4, everybody? It's actually 0. Uh-oh. What do I have to do with this ratio to do secant, though? What do I have to do to this? Flip it. What's 4 over 0? Undies. Your calculator, if you had a secant button, which you don't, most don't anyway. If you secanted 270, it would say math error. Divide by 0 error. Might be one of those two. Tangent is, uh-oh, what number over what number? Ticks, it's what? What's -4 over 0? Undies. And then what's cotangent? I got no time for this. 0. Hey, you do have a tangent button. Type the tan of 270, press enter. I just want to see what your calculator says for an error. Everyone will say a little different error, I bet, different script on it. Here's a game you're going to play, and I'm going to actually play it right now with 2 more examples. All right? And we do have time. I'm a little bit ahead of the other class. This is what just happened to you. What angle measure did I say we just dealt with? What did I just say we dealt with? What angle measure? 270. So why doesn't it say 0 and -4? Because how many coordinates are on the y-axis? How many coordinates? Starts with an I. I don't have time for this. Infinite. What's the easiest, smallest coordinate for a y-coordinate? 1 or -1, right? So this represents, hey, all those quadrantals, when we trig them, we're going to have to play circ-kicks or ticks, and we might have to make up our own coordinates where these things cross. So 0 degrees seems silly. That's 0 movement, right? But this is 0 degrees. This is the triangle. It's not a triangle, though. So what do? Okay, how do I go right? What kind of number is that right? Positive or negative? Positive. What's the smallest, easiest number to deal with? 1. So I shall say 0 degrees crosses coordinate 1, comma 0. Therefore, r is equal to what? R is the distance back to the origin, which is 1. Or I have 90 degrees. Okay, here's 90 degrees. Well, I have to take the sine of 90 degrees. How am I going to do that? I'm going to make up a coordinate. The easiest coordinate in the world is 0 left and right, and how much up? 1. So 0, comma 1 is the smartest coordinate to choose. Therefore, r is equal to what? 1. The last one I'm going to explain because we already did 270. Hey, I have to take the cosine of 180. I don't know how to do that. Oh, I'll make a coordinate. What kind of coordinate goes left? Negative. And it's -1 for x and what for y? 0, because I can't go up or down. So this terminal side right here happens to pass through -1, comma 0, where I can make r equal to what now? 1, because it's only 1 away from the origin. And then you're going to play what with this? Sir, Kixer, Tix. You have to, because there is no triangle, so there is no SOHCAHTOA. Not going to do it. Okay, and then no way, you're going to have to do this for me. That's just a chart of what all the values would be when you actually trig that stuff. You can look at that on your own. Don't be putting your stuff away, so I'm going to call on somebody here. Where does 450 degrees land? Stop. What do you know about 450? It's more than what? More than, actually, 360. Which way do I have to move for 450? You know the calendar, right? Which way do I have to move? Counterclockwise. How far have I moved right now just to speed this up? I've moved what so far? 360. How much more do I have to do to get to 490? 90. Now, based off of everything I just showed in the chart before, this is the terminal side now. I have to pick a coordinate. What would be a smart coordinate so I can play Sir, Kicks, or Ticks? What would be a coordinate that passes through? Just going up. 0, 1. What's r? What's r then? What's its value? 1. Next person in the group. What's tan? Tan of an angle measure equals what letters? Boom shakalaka, because of Sir, Kicks, or what? Ticks. Then the next person in the group. What's the final answer then? What is 1 over 0? Oh, undefined. After all that, we got nothing. An undefined answer. That is true. Okay, not to bother anyone because of time. Which way do I go for -450? Which way do I have to go? Clockwise. How far have I gone right now just to speed this up? Clockwise. So where do I have to go now? Down here. What's this coordinate, everybody, that I could pick and make happen? 0, -1. That's x, that's y. What's r equal to? Hey, what's cosecant? Who is that related to? Sine is Sir, so cosecant is r over y. That's what you're going to have to do now. Now it's done. What's r? 1. What's y? So this is -1. And then just because of time, I don't have to... This one I think is just a bunch of rotations. I think it ends up being the positive x-axis when you're done. Subtract 360s out. All right? But if I have time, I'll go back to that. This is what I'm worried about, and this is a good end to the notes. Now, there is some questions I did not cover that analyze that are in the homework. You should be able to read it and figure out what they're asking, but I could come back to it. The reason I want this one is the last part. Do you see that 5 cosine? What does that say in the cosine? Squared. I'll help you right now, so you know what this means. This actually means you take the cosine of 180, get that answer, and then square it. This is just a mathematical notation situation. Okay, that's the way they like to write it. So what it says is to evaluate this. So this is how you're going to do it. What I want to see until you become masters is draw these angle measures in question. I have 360 degrees got a tan, and then I have 180 I have to tan. And I'll use the same drawing for these two. So 360 without, having the time to analyze this. This is 360. And now what I have to do is pick a coordinate because this is coordinate trig. What's the coordinate that this terminal side passes through? This is right how many? Why 1? And the answer is because it's easy. What does that make r? 1. Okay, yet again, what's the tangent of 360 then? Tangent's ticks. So what's the tangent of 360? 0 over 1. So you replace this with its numerical ratio after you tangent it. By the way, what's 0 over 1? So right now I have nothing. Now 180. What's that coordinate that 180 crosses through? It's not 0, -1. That's a common mistake. It's -1 right, left I mean, and then 0 up or down. Now I can use this for both of these pictures. 4 times, this is what it means. 4 times whatever the sine of 180 is. So be careful on that. By the way, what is the sine of 180? Oh no, sir. Hurry up, everybody. 0 over 1, which is what 0 over 1? Right now I have nothing. Boy, this is fun. Plus 5. Now, this is what I mean about what's that cosine squared mean. It means cosine of 180, then you square the answer. Now look at 180. What's the cosine of 180 if cosine's kixer? I'll tackle you like that. Oh, go ahead. I'm ready. I've been waiting for this. -1 over 1. What's -1 squared? Answer it. 1. What's 1 times 5? After all that, this expression is equal to 5. Got it.